All right, this is lesson 16, patterns and sequences. So inductive reasoning is the process of analyzing patterns to make a generalization about the pattern. These generalizations include determining the next value in a sequence, writing the equation that creates the sequence, and finding an unknown term. So for example, finding the 100th term of a sequence, or finding the 50th or 1/50th. Inductive reasoning can also be used to graph the pattern. So an arithmetic sequence is defined as a series of numbers that have a common difference. So a simple arithmetic sequence is 1, 3, 5, 7, 9, 11. So each term you're adding 2 to it, or you're subtracting 2 from the previous term. In this sequence, the difference between each number and its preceding term is 2. So 3 minus 2 gives me 1, 5 minus 2 gives me 3. So the formula to find the value of any term, if you know the term number, is a sub n equals a sub 1 plus n minus 1 times d, where a sub n is the nth term, a sub 1 is the first term, and n is the number of terms in the sequence, and d is the common difference between the terms. So in the example above, a sub 1 is 1, that's the first number, and 2 is the common difference. So what are the next 3 terms of the sequence? -2, 5, 12, 19, 26. So since the common difference is plus 7, we're adding 7 to 26 yields the next term, 33. We then add 7 to 33, which gives us 40, and add 7 to 40, which gives us 47. I want to find the 18th term of the sequence 4, 9, 14, 19. I find the values of a sub 1 and d, okay? Now I could find the difference. There's a plus 5 in between each of these. So I could add until I got to my 18th term, but this is a lot easier. So the first number is 1, and my difference is 5. We know that the value of n is 18. So I use the formula and substitute in all given information from step 1. So a sub n equals a sub 1 plus 18, or n minus 1 times d. Well, a sub n, that's what we were trying to figure out, equals a sub 1 is 4, that's my first number, plus the term we're trying to figure out, 18, minus 1 times 5, which is the difference, which gives us 89. So the 18th term of this sequence is 89. A test-taking tip: the formula for an arithmetic sequence is not provided on the reference sheet. In a situation where you do not remember the formula, you can use your calculator to repeatedly add the common difference to find the nth term. Geometric sequence. A geometric sequence is a series of numbers in which consecutive terms have a common ratio. So for example, 2, 6, 9, 27, 81. In this example, each term in the previous term multiplied by 3. If a sequence is geometric, there is a common ratio, then a common ratio exists between the terms. So to determine if the following sequence is a geometric sequence, if it is, find the next 3 terms. 6, 12, 24, 48, 96. Since 12 equals 6 times 2, 24 equals 12 times 2, 48 equals 24 times 2, and 96 equals 48 times 2, the common ratio is 2, and the sequence is geometric. Therefore, the next number in the sequence is 96 times 2, which equals 192, followed by 192 times 2, which equals 384, and the next value is 384 times 2, which gives us 768. Writing patterns algebraically. Patterns can often be written as an equation. That equation can be used to find additional values. Both algebraic and geometric sequences can be written as equations. As we have seen in the previous examples, but other sequences can also be written as equations. To write the equations, determine how each following number is created using the previous number. Some possibilities include adding or subtracting the same value to or from each previous value, multiplying or dividing each previous value by the same factor, or raising each previous value to a power of 2 or more. So example 4, write an equation that represents the following sequence: 476, 563, 650, 737. To create an equation that represents the sequence, I determine how the next term is obtained from the previous term. It is clear that each value is not a square, cube, or other power of a previous term. Since the terms are increasing, division and subtraction are not possible as the operation. However, subtraction can be used to determine the pattern. 563 minus 476, so I take my first 2 terms and I subtract them, I get 87. I take my next 2 terms, I get 87. and I take my last two terms and I get 87. Each term increases by 87. This is an arithmetic sequence. Therefore, the value of D equals 87. And since the first term is 563, when n equals 1, 467 minus 87 equals 389. Therefore, when n equals 0, the first value of the sequence is 389. Therefore, one equation is 389 plus 87n. The equation in the simplified form of the arithmetic sequence exchange equation, a sub n equals a sub 1 plus n minus 1d, where a sub n equals 476 plus n minus 1 times 87, when n equals 1 and a sub 0 or a naught sub naught equals 476. 476 equals 476 plus 1 minus 1 times 87. Simplifying the equation, a sub n equals 389 plus 87n. On a multiple choice test, it may be best to test the equations that are given until you find one that works for all cases. Remember that n is used to denote which term is being used in the sequence. The first term, 476 in this example, is represented by the value n equals 1. This is how you can check your work in example 4. So here's my first equation. I should get a of n equals 476. Okay. Since the equation produces all the values in the sequence, the equation represents the sequence. Example 5. The value of a baseball card increases at an annual rate of 125%. If the baseball card started out at a price of $75, how much will the card be worth in 3 years? Since the monetary increase changes every year, the sequence is not arithmetic. However, the sequence does increase by a factor of 125% or 1.25. Therefore, the sequence is geometric. The table below outlines the amount the baseball card is worth each year. So after year 1, it started at 75 plus 1.25 times 75 equals $168.75. At year 2, 168.75 plus 1.25 times 168.75 is $379.69. After year 3, it'll be worth $854.30. Therefore, the value of the baseball card after 3 years would be $854.30. All right, that is the end of lesson 16. Go ahead and work on the exercises.